Yes, class, good morning. Today discuss a new topic, very important topics, permutations and combinations. What is the permutation? What is the combination? The simple meaning. First we discuss a simple meaning of this topic, permutation and combination. Permutations here, this is the arrangement and combination here, the selections. What is the arrangement? What is the selections? Suppose you have the any things, any letters, any counting numbers, everything you first you will be select, then you will be the arrange. Without selection, arrangement is not possible. First you will be select, then you will be the arrangement. Suppose you have A, B, C, D, E, F, 6 letters. Suppose you have these 6 letters. The first will be select the letters, then will be the arrangement. The first will be select the letters. After first will be select the letters, then we will make the arrangements. So how to select is means you have required the 2 letters word, 3 letters word, 4 letters word, 5 letters word, and maximum here 6 letters word. So you can maximum letter here 6. If repetition is not allowed, if repetition allowed, then more than letters here. But condition here is suppose you have the 6 letters, or you have required only 3 letters word. These selections of 3 letters. You have choice only any 3 letters here. So then what is the selections of this? This selection here A, B, C. Suppose your first letter, first word here A, B, C. Next, suppose A, C, D. Next, A, D, E. Next, A, E, F, and so on dash. And many selections here. 3 letters select 3 letters for selection. Many selections here. And example taking 1, 2, 3, 4. Here many selections. But then this is the selection of the suppose requirement of the 4 letters, then A, B, C, D, 4 letters. Suppose you have 4 letters. Suppose you write here selection of the 4 letters. So how many selections? Selections of 4 letters. Then A, B, C, D first. Next A, B, C, E in this way, A, B, C, F in this way. So this is the selection of the 4 letters. This is selection of the 3 letters. Suppose similarly 5 letters, similarly 6 letters. The first you make the selection of the letters. After that you arrangement. Arrangements. So suppose I am taking the selection of the 3 letters here. 3 letters means A, B, C. So how many arrangements of this? How many arrangements of these selections? How many arrangement of these selections? How many arrangement of these selections? How many arrangement of this selection? And so on. Same way. Similar thing. How many arrangements of every selection having the different arrangements? This selection having different arrangement. This selection having the different arrangement, this selection is having the different arrangement, and so on. So, first example I am taking the first selection A, B, C. So how many arrangements of this selection? A, C, B. This is possible. Suppose A, B, C, A, C, B. Next selection here C, A, B or C, B, A. Second, first A, B, C, A, C, B. C, A, B, C, B, A. Our next selection here B, C, A or B, A, C. So how many selections of this? How many selections here? 6. 1, 2, 3, 4, 5, 6. So 6 arrangements here. In this selection 6 arrangement. Same things here. This selection 6 arrangement. Same things here. This selection having the 6 arrangement. Same things here. This selection having the 6 arrangement. So how many selections here? Every selections of in this 3 letter selection having the 6 arrangement. Same things here. Suppose here A, B, C, D 4 letters. This is a different arrangement, the different arrangement. It means the total number of the total numbers of the arrangement is total numbers of the arrangements. The total numbers of arrangements are called permutation. The total number of arrangement is called the permutations. The total number of arrangement are called the permutations. This is the only first selection arrangements. Similarly, here then this will be add, then this will be add, and this will be. The permutations means total number of arrangements are called the permutation. This is called the permutation. This is the example. I am giving only single example of the first selections. In this matter, similarly, we will be count these arrangements of the second selection, next selection, then how many selections, then every selection we will count. Then this is called, all over is called the permutations. You can addition or multiplication. These are different rules. Addition rules and different rules. So this is the simple meaning of the permutation and combination. Yes, note down it. Then next. Yes, class. What is the definite meaning of the permutations here and identity of the permutations here? Permutations. A permutation is the arrangement in a definite order of a number of distinct objects. Permutation always applied when the objects are different types. First, different types and same kind. Both conditions are different. When objects are different kinds, then identity is different. When some object are same kind, then identity is different kinds. So when a number of the distinct object taken sum, when all object, first case, all object are the different kinds. So then the total number of object is n, or object taken at a time is r. So what is the permutation of this? So then permutation P and PR. Yes, you can say this is P and R. This is represented by permutation represented by the NPR. Otherwise, you can represent P and R. What meaning of the NPR? Yeah, P and R. NPR equal to factorial n upon factorial n minus R. This is what is the value of the R? 0 greater than equal to R less than equal to n. Where this means number of objects are you are taking here. The minimum 0 or maximum is the n, total number of the object. Where are you taking? So, example here. Suppose you are making R 6 digits. So this is the number of digits here 6. Or how many digits are combination? You have 3 digits. So then n equal to your 6 or R equal to your 3. So you are making the word 3 digit letters. 3 digit you are making the combinations here. Total number of digits here, letters here 6. Or how many letters are using in this word? A single word is 3 letters. So this is a 6 NPR, 6P3. You can write in this way. It means, for example, this NPR means factorial n upon n minus r factorial. And what is the meaning of the factorial? Suppose you are writing the factorial n. This is the meaning n minus 1, n minus 1, n minus 2. In this way you go this, then this you go that. And every time you will go the n here, n minus 1, n minus 2, this n minus 3, n minus 4, n minus 5. This is one digit will be less this here. Suppose example, suppose you write a factorial 5. This means 5 into 4 into 3 into 2 into 1. So this is your meaning of the factorial. 5, 4, 3, 2 and 1. Don't repeat here 1. This is a 1. So you multiply, you get the answer of the factorial 5. Suppose factorial 3 here, then factorial 3 means 3 into 2 into 1. So this is a 6. So means every time you will be going the descending order. Factorial meaning you are going the descending order here. Factorial 5 into 4 into 3 into 2 into 1 in multiplication form and descending order. And here 3 into 2 into 1, then multiply, get the answer is 6. The factorial 3 means 6. Similarly, factorial 4 into 3 into 2 into 1. The 4 3 is 12 is 24. This is the meaning of the factorial 4. So means meaning of the factorial means you are going the descending order of the 1 digits. So this is the identity of the R when and different kinds of objects, different kind are number of object are you taking here in a word in a group in R object. The total number of different kinds of objects is n, or how many objects are you taking one times, this is the R object. Total number of objects, different kinds of objects is n, and how many objects are taking in one time, this is the R. This is called the NPR, permutation of the objects. Yeah, letters, yeah, words, anything here. So factorial n upon factorial n upon n minus r factorial. This is the identity of this NPR. Suppose second case, the objects are different kinds. Or here repetition is allowed. Repetition is not allowed. Here repetition is not. R and A. Repetition is not allowed here. R and A means repetition is not allowed. But when condition here ki repetition is allowed, if condition is RA, then what value of the NPR? Then n factorial R, n power exponent. This is a different kinds of object. Same things here. N objects, different kind of objects are you taking are one times objects? So, but condition here repetition is allowed. So then identity here n exponent R. And when RNA condition, so then for identity here factorial n upon n minus R factorial. Condition is same thing. So both the identity are different here. Repetition is not allowed, or repetition is allowed. Next things. This is the first identity, second identity, and third. Suppose n different kind objects, but P objects are the similar, and other are total number of objects are P. Suppose total number of object and total number of object is different kind is the n. Total number of object here n, but n having this some P are the P having the same kinds. Out of total number of n, P having the same kinds, but rest objects are different kinds. Or total number of n objects, then P objects having the same kinds, but rest are the different kind. Then what is the identity of this? So then when P object are same kinds, when P objects are same kinds, then value of the NP, then permutation of object, then permutation of objects, factorial n upon factorial P. How many kinds of this factorial n upon factorial P? Total number of objects here n, total number of objects here n, or P are the same kinds, then you can add factorial n upon factorial P. Here no any same kind. Here in this condition all are different kinds, in this condition all are different kinds, but here things repetition is not allowed, here repetition is allowed, but here third condition here is suppose some objects are same kinds. Suppose your room, you are writing your room, but two O are the same kind. How many letters here? R, O, or M, 3 letters. But O here 2 times here, room. But then O here that P factorial P. Total letters here 1, 2, 3. Total here there 4. But 2 factorial 2 will divide with O here repeating here. The factorial 2 divided by here 2. Because value of the P here 2. The factorial 2. Because O here repeating here 2 times here. The same kinds O. Suppose more than. Suppose M repeating, R also repeating, then you can write here. Suppose number of object here more than repeating here, the factorial P, factorial R, factorial Q, P, Q, factorial Q, factorial R, factorial S. The number of factorial P are the same kinds. It means factorial Q are the same kinds. Factorial S means same kinds. That means those are you are dividing these letters. It means these letters are same kinds. Then you divide by. Only single letters here same kind. Then this. Suppose there are 3 letters here same kind. Then you divide P, Q, S. More than R also here. The number of letters, how many numbers of letters are repeating the same kinds here, then you divide by P, Q, S. Only one letters, then you only one letters are repeating here, then you write the factorial P. Suppose 2 letters are repeating, then 3 letters are repeating the P, Q, S. Then the number of way you can divide by this. The 3 identity are main here. Is suppose repetition is not allowed, then write this. Repetition is allowed, then this. But here repetition is not allowed. When P is the object same kinds, then permutation of the object here factorial n upon factorial P. But this condition sometimes is changed. Change means suppose number of the P kind things is repeating, number of Q kind things also repeating, number of S kind things also repeating. Then you divide the in this way, factorial n upon factorial P into factorial Q into factorial S. Suppose more number of things are repeating, then you write the in this way. Suppose only one things are repeating, then you will write it in this way. Yes, note down it, then next. Yes, then next point I am taking here, fundamental principle of counting. This is a short form of this FPC. This is a very important in the permutation and combination. This is a very important role of this. So what is the fundamental principle of the counting? Means this is the counting process of the fundamental principle. Here 2 methods here. First here principle of multiplications, or second principle of the addition. The fundamental principle of counting working in the 2 way. First multiplications method, a second addition method. This is the symbol of this AND, means both will be, suppose 2 things, 3 things, any number of things you are giving, then selecting everything is, or here only selecting one thing. This is a independent, this is a dependent, this is the independent. 4 examples here. Suppose in a class number of boys 10 and number of girls equal to 15. For example, in a class number of boys is 10 and number of the girls is 15. How to working this multiplication rules, or how to working this addition rules? Suppose selecting the monitors in this according this AND, it means girls and boys both having the separate monitors. Girls having and boys having here the separate monitor, this is the AND. Or girls and boys having only one monitor, this is called the OR. Not having the both, only one monitor, or girls and boys only one monitor, it means this is OR conditions. Or when girls and boys having 2 monitors, then this is condition is called the AND conditions. So according this way, the number of way, how many boys here? 10 boys. 1, 2, 10 boys. The number of selection process of the boys is 10. How many girls here? Number of selection of the girls 15. So now by FPC, number of ways selecting two monitor. Suppose two monitor is selecting here, क्योंकि यहाँ independent, here independent, here dependent, but two monitors, then number of boys here 10, the number of boys is 10, and how many number of girls here 15, the number of selecting 15 way, 10 boys, number of selecting with any boys are selecting, suppose any boy is selecting, then 10 ways, 10 way, or number of girls selecting 15 way, the total number of way equal to 150. Only selecting two monitors, selecting here two monitors according this way by FPC. Number of ways selecting one monitor, only one monitor, because here girls and boys having selecting this independent, girls and boys only one monitor selecting here, means this equal to number of ways selecting of the boys is 10 plus number of girls selecting is the 15, then 15, this is the here 25 way. Answer here different. Answer here different. Answer here different because your condition here different. According this way 25 way, according this here 150 way, because you are selecting two monitor. This is the girls and boys. The girls selecting of the boys is 10 ways, selecting of the boys is the 15 way, total here way is 150. And by FPC here, FPC means fundamental principle of counting, short form of this FPC. Number of ways selecting only one monitor. In this condition, only independent means girls and boys having only one condition, not both. Or means girls and boys only one. Then you are selecting not both. In this condition you are selecting only one, not both. In this condition you are selecting the both. Girls or boys is separate way. In this condition you are selecting separate way. Suppose two things, then you select two. Suppose three things, you will select three. Suppose four things, you will select a four. In this way you are separately selecting, but in this way you are selecting only one. Or means girls and boys only one way, then you are selecting number of 25 way. So this is the example of the fundamental principle of the counting. Second example also here. Yes, you note down it. Yes, students. Second example of this here is suppose you have the five. Suppose you have the 5, 1, 2, 3, 4, 5. 5 digits. You have the only 5 digits. And here two conditions. You will make the 3 digits numbers. You are making here the 3 digit numbers. Repetition is allowed or repetition is not allowed. The first condition here, you will make your 3 digit number. How many digits here? 3 digits. 3 digit number. Condition first here, repetition is allowed. RA. RA means repetition is allowed. RA. In short form RA. Repetition is allowed. Or second condition here, repetition is not allowed. Repetition is allowed. 5 digit here given. You will make the 3 digit numbers. Both conditions. First condition here repetition is allowed. Second condition here repetition is not allowed. The solution start here. In first condition, when RA repetition is allowed, total numbers of here total digits are 5, but you are making here the 3 digit number. Then you will make here 3 boxes first. 1's place, 10's place, and 100 place. 1's place, 10's place, and 100 place. 3 digits. 1's place, 10's place, and 100 place. Or you are making the 3 digit numbers. Our condition given here repetition is allowed. But then number of way to fill one's place equal to 5, because you have the 5 digits, so you are fill all any digit here, you are fill any digit here, then 5 way. Second, number of way to fill is tens place, this is also 5, because repetition allowed. Suppose you are using the 1 2 3 for any digit here, the same digit here you can repeat here, then in this place you can it is a 5 way, this digit, this place you can fill the 5 way, or this place also you can fill the repetition is 100 place, HUNDRED 100 place equal to 5 way. Means every place is 5 way, 5 way, 5 way, because repetition is allowed. Then by FPC total number of ways to fill 3-digit number equal to 5 into 5 into 5, this equal to 125. 125. The total number of ways fill here 125 ways. This is your answer. Second conditions. Second condition here, when repetition is not allowed, when R and A, then same things you make your 3 boxes, first, second, ones, tens and 100. First, suppose your fill only repetition is not allowed, means suppose your 2 digits are your fill here, this will be not fill here. Repetition means suppose your fill here 5, so here left only 4, here the 2, suppose your fill here the 2, how many digits are left? The 3 digits, here this place will be fill here only 3 way. The number of way to fill one's place equal to 5 way, number of ways to fill tens place equal to 4 way, or number of ways to fill the 100 place 100 place is equal to 3 way. Suppose maximum chances to fill in the ones place, because you are having the 5 digits here. Suppose you are fill here the 5 here, how many digits left? 1 2 3 4, so you have choice only 4 digits. Next, these 2 places are filled, so any 2 digits are covered, how many digits are left? Then 3, here you have only choice here 3 way. So then by FPC total number of way equal to 5 into 4 into 3, 60 way. This is your answer. But both answers having the different here. This is the repetition is allowed, or this answer here repetition is not allowed. In this depend on the conditions, to which condition you have given. Repetition allowed, the answer will be different. Repetition is not allowed, answer will be different. Yes, according this way you will solve the every questions. Yes, no doubt.